Anybody remember what we were doing last night? Yeah. What? Yes is not the right answer. Clearly it's an incorrect answer too. No?
We're
Is that what the
like,
web?
tricking, we're like tricking servers to, infiltrate things.
That sounds like the description of the course.
Yeah.
Yeah. What type of service were we tricking?
SQL, SQL.
No, yeah, yes. We're talking about the web, right? So yeah, we're piggybacking on how applications interact with SQL, especially web application. We try to get information from a web user and then shuttle it into SQL, and we can add commands. Anybody remember this? What was it called? Single injection, that's right, yes. At least that was taken away. This is good. And then we talked about another thing. This is called, what's this acronym over here? Cross-site scripting. What is cross-site scripting? Anybody? Anybody remember what this was?
You infect the server such that it infects other users.
Yeah, so in particular the stored version and exactly that. So effectively you're saying you're putting things on a server, in this case, on somebody's web server. Suppose, let's take an example. You guys are uploading stuff to, let's say Facebook, right? And you're putting in a caption for an amazing picture from whatever you did last week. And in the caption, you lace it with a little bit of HTML, maybe even JavaScript, if you're really pushing. Then anybody who goes in their browser and looks at your picture, if Facebook didn't have protections against this, the browser would just try to print out the text that you put in there, including that HTML, including that JavaScript, and execute under the privileges, as if this was something that Facebook intended for you to run. And so that could be something like, hey, send your Facebook password to this person over here. Or, more commonly, hey, add or like stuff on Facebook, like this page, send messages to your friends, hey, check out this link, and all this stuff, right? That's how Facebook viruses come to be, right? It's through these types of attacks. We call cross-site scripting. We're tricking a site, we as an attacker, are tricking a site into having it store stuff that will then trick other users into executing stuff they don't want, as if it came from that site. That's what we're doing. Does that make sense? That wasn't the answer I expected. It's kind of weird, right? So we're going to, let's spend a little bit of time on this so that this is clear, right? Here, I'm evil here. That's a really weird thing. Yeah, it's a cute little cat. It's supposed to be a very evil kind of adversary here, okay? And he has horns. This is why I don't draw in class. See this? Okay, clearly I failed art class. Okay, this is evil, fine, okay? Unambiguous enough. This person is evil, okay? And then there's this like another guy here, another person who is good and happy, has a halo. Okay, good. Okay, so far we're talking together, right? And then there's this server over here. Okay, it's just some box with some numbers on it. This is a server. All right, what are we doing? So the evil guy sends content to the server. What is it sent to the server? Sends it not just their name of like, I don't know, evil. It sends in additional content. Say evil, and then also a graph equals, like some HTML, maybe even script opens JavaScript, or like, let's say, document dot whatever. Does all this stuff. So this whole package over here, which I'll put in a differently colored chalk if I can find differently colored. It's all evil stuff over here. This all gets stored by the server. Now anybody who's good comes in here and normally talks to this web server, gets a copy of this green box, thinking that it's just regular content from that web server, and then when the browser looks at it, it has no way of discerning what came from where, and just sees like Okay, here's text, I'm supposed to render text. Oh, there's an anchor over here. Oh, look, it's a script. I'm supposed to execute the script and so forth. And there's nothing that indicates in the browser that there should be anything running under any different privileges than just anything that's running from that server. So if this is facebook.com, it's like facebook.com generated. This is cross-site scripting. Makes sense now? Good, okay. Great, okay. So stored XCC is where you upload it and a lot of people can view it. And that means that we're not just attacking a particular person, we're attacking a bunch of people. So for instance, I put in like a guest book on some site, let's say it's something like Facebook. I go in here and I say, instead of saying just a test comment, I can put in HTML, like, hey, this is bold. So I put a bold in here. I can go even further and say, hey, put a script tag that say, pops up an alert or something. And then that will happen for anybody who visits that particular page. Their JavaScript is involved in an alert. And of course, you could then do more nefarious things. You can, for instance, get their session IDs, which are effectively equivalent on the web to your password. You can take over your Facebook session, or your bank session, or whatever. So, this is the name of the game. I'm evil over here, so this is the person with the horn. So we're on the same page. Sends in here a comment. It has document thing that says, hey, go to evil.com, and the URL you can send it here is going to be your cookie. I'm going to steal your cookie. That's what we're doing here. That's the nefarious thing to do. So here's LAPD Online, which is supposed to be a very legitimate source of information. And some other person goes in there and like, hey, I'm going to like look at this page. And when they look at the page, they see that there's this content from a previous user that happens to have this script tag in it. So the browser on this person's computer is going to execute and it's going to go, oh, instead of being on this page, I'm supposed to change my location to evil.com, and the URL, like the actual page that I'm visiting, is the cookie, which is now recorded by the evil page. You go to evil.com, and this is your cookie. And now, this evil person who probably controls evil.com can get that cookie, walk into lapdonline.org, present the cookie, and proceed with with all the same privileges as this user would. Remember, when we log in on the web, and even if you use two-factor authentication and all this stuff, we tend to then just have a session with that server, and anybody who has the same session identifier or cookie can do the same thing. Now, of course, if you wanted to have some protections against this, you might add things like, hey, somebody's logging in, but their browser is completely different than the browser gave the cookie. Maybe I should ask them to re-authenticate, or maybe I should ask them security questions. You can have those types of checks, but those are just checks, right? In effect, you've confused who is whom on the internet because of the setup here. So, this is another aspect of stored cross-site scripting, is that you have tons of different victims. In fact, it has that watering hole, and like anybody who comes to the site is not going to get infected. Of course, this is a favorite target from spammers. If they can find any page where they can put in content that's going to infect anybody who goes to the page, of course they will, right? So if your domain expires and it had some page rank, it was liked on the internet, somebody's going to buy the domain and they're going to put this kind of stuff. You have an ad slot and you're not sanitizing enough, like double click. I had apparently some problems with this. Then an evil attacker is going to come in and they're going to put content like this. So anybody who opens up a page that has a part of the double click network has an ad on it, it's going to get infected. Okay. So how do we mitigate this stuff? The problem at its core is this lack of sanitization, right? That I don't just put in a name, I put in something that's going to be interpreted by a browser to be browser commands, like HTML or JavaScript. Like I'm effectively executing arbitrary code on people's computers. Every time I go on a website, that's what's happening. We've spent most of this course thinking about how we could possibly inject code into other people's C programs, right? We've gone through a lot of hoops to do so. And along comes the web, where the default mode of execution is execute code that somebody presented to you in a text. From a security standpoint, this is the Wild West. And that's what's happening when you surf the internet. Now, sanitization is a little bit like rolling your own crypto, right? If you want to sanitize properly, yeah, you're going to have to chase a lot of things. So don't roll your own crypto, don't write your own sanitization, because remember this stuff from last time? Well, if you just remove cases of script, just put script instead of script. Well, let's do it recursively. Oh yeah, well, we just use a different way of triggering JavaScript. And there's tons of these scripts, right? Oh, but I just don't want it to run some particular command thing like alert. Well, lo and behold, we have this weird thing that some browsers will execute and some not, because they'll just drop off the most significant bit and things just happen. It's crazy. Absolutely hard to do this properly. Then there's the frontier sanitization. So it's trying to say, like, every time we connect to a site, we're going to try to get rid of all kinds of input, right? We're going to say, like, oh, if you have any SQL commands in here, we're going to get rid of them. If you have any JavaScript in here, we're going to try to get rid of it. So, but then there's the question, like, do you do cross-site scripting then SQL? Or do you do both personally? Like, how do you do that? So why is this a problem? Well, suppose you have the following scenario. Let's just look at how elaborate this attack is going to become. This person puts in here email and then a quote. Why is a quote interesting? What kind of attacks get triggered from quote? SQL injection, right? You're trying to break out of that quoted string that's going to the SQL server. And so the sanitizer here, this frontier sanitizer, is going to go like, hey, it's a quote, it's probably bad, let me just put a backslash here and then remove the backslash before I present it back to you. Great, okay, so it's been sanitized here. Then we insert into sessions, username and password, and look, it's fine. There's no flaw here. There's a backslash, so it gets interpreted just a literal quote, we don't break up, perfect. And then we're going to select from all the sessions later in the lab here. We get all the sessions back and we get things like Evo quote, right? Because that's how it gets stored. Now we have a second selector. In fact, you have hundreds of these. Usually when you open up Facebook, you're sending hundreds of requests to hundreds of services. And that second one thing we can sanitize this nicely. So what should we really have done? We should have had like kept the quote on it something, or like when we read from here, we have to like maintain quotes on it and then strip the quotes. It's really complex to do it right. So here, like things just break apart, right? Yeah. I can hear my heart. Okay, that's the most muffled laugh I've heard. Okay, sanitizing once isn't enough, and that's like, yeah, it's pretty bad things. What about context-specific sanitization? So like, hey, let's sanitize SQL around the SQL. Everything that gets sent into the SQL server and comes back is sanitized separately. Everything that goes into a website and comes back is cross-site scripted sanitized. Right? Can we do that? Yeah, that's something that we can do, but use the libraries, the built-in libraries, for whatever language you're coding in. It will be more successful than trying to do it on your own. You will in some cases. And this is something I wanted to show you maybe at the end of classes. Here's a page where you just go through this kind of this feast of various problems that have existed in various websites. Try to see how easy it is. Anyway, so yeah, I'm using the slides here by Dave Brumley. Let's talk about a new kind of attack now. Cross-site request forgery. What is that? That sounds a lot like something cross. Yeah. Easy to get this confused. So here, what you're doing, well, okay, let's go back and distribute here, right? So members, why do we have session cookies? Because HTTP stateless, right? Every time I send a request to a server, they're like, I have no idea who you are. They don't store any information about who you are. So you have to present information like, hey, grandpa, it's me again. Here's a picture of us together, right? It's that type of relationship you have with your web server. So a cookie is something you said, hey, I want to push this login thing, and the server's like, oh, you're authenticated. Yeah, I know you. I'm going to give you this token here, this cookie that you're going to present so that I will recognize you in the future. And then every time you do things, you want to get some website or anything, you post as a part of the header your cookie, your authentication thing. And then the server's like, oh, right, it's this person. And you get a response, right? And then send them every request, whether or not it's an intentional request or not. Now, what do you mean intentional? Let's look at a very interesting attack, right? So here are the good guys and the bad guys. So there's a bank in the picture. The bank here on the right. This is a half-eaten cookie over here, right? And here's evil.com, or the Farius Nemesis. Okay? So I authenticate here with my bank, and I see this very low balance coming back. But as I authenticate, I get this cookie, right? So that I can maintain my connection with the bank without having to authenticate on every single request. And then I decided, I don't know, my grandson, I think, I decided to transfer some money to some person, say $500, okay? And that's a part of this transfer, I sent my cookie. Cool, right? Everything's good. Now, suppose that, oh yeah, let's check it out. Suppose that we change the picture a little bit, and there's this evil.com place here. And there's a site. Suppose that this was something like LSPD online, or it's just a site that I went to accidentally because I was, I don't know, trying to steal something from the internet. Or whatever it is. So for whatever reason, I've ended up on this page, or something that this attacker controls. And they have an image here. The image is bank.com transfer 10,000 to Evil Corp. Now, a few things. That's not really an image, is it? Do you think your browser cares? Browser's like, oh, it's not an image, but I'll try my best. So your browser here is going to go ahead and say like, oh, there's supposed to be a picture right here. La 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 la. I'm going to go to bank.com. I'm going to send this request, and get this thing back like, you transferred money. Oh, I'm going to interpret it as a picture. Well, it kind of doesn't look like a picture. I'll just put text. Crazy, huh? Your browser is so lenient, it's so trying to adhere to anything that you might intend to do, that is sometimes this stuff that's complete nonsense. So, right now what's happening is that you have an image, it doesn't even show, so somewhere, like one pixel or something on your screen, you've actually made a transfer. So, you connected to bank.com, and because you've already authenticated against bank.com, you already have a cookie. Your browser is helpfully going to send the cookie along with that image request, even if you didn't intentionally make this request. Right? Crazy, huh? This is called a cross-site request forgery, right? So this person now gets $10,000. Of course, we try to have all sorts of checks and balances in place right now to have like, you have to enter a PIN, you have to do all these things when you do a transfer, right? This is why. So, yeah, okay. So, it's more, if you come up with the definition here, a cross-site request forgery causes the end-user browser to execute unwanted action on a web application on which it's currently authenticated. You're authenticated, somebody else makes use of that by saying, as a part of my page, you're supposed to do this weird stuff on the authentication page. So the style is CSRF, XSRF. Here's another example. So you all have these guys at home, right? Everybody has a home router, I presume. Has anybody played around with them? You can also say yes instead of nodding your head. It's so silent over here. Please talk to me. Okay. Anybody played with this? Like, has anybody like fiddled around and be like, oh, it does this stuff? Huh? Yes, you have. Yeah. Yeah, it's a fun thing to do. Anyway. So here's something you can actually do. So you know how many people have changed the password on these? Oh, okay. How many people of you are lying? Okay, you did actually change the password on it. Good, okay. So all these people are like, yeah. Because it's in my network, who could ever access it? Well, I ask you, who could ever access it? Let me guess, this is one of the 3 default IPs, like 192.168.0.1 or 11 or 1254 or 10. Yes, yeah. Well, guess what the attackers know as well? They have all the default passwords. Admin password, admin links is. Yes, that's right. So what you can do is now, on any page that you go to that has like, oh, free iPad, or like, oh, you're gonna download Game of Thrones, it's right here, yeah, just come on this page, yes, come on in, right? There's gonna be a little iframe or whatever that's gonna say like, hey, that's the malicious page over here. And a part of the page is gonna be like, hey, by the way, like that image over here or something like that, it's actually on IP 10.10.10.10.10 or 192.168.1.168. And if you have actually gone and configured your router and you have a cookie with it, something like that, well, guess what you can do? Change this access, say like, hey, open everything here up from the internet. Make me a part of the biggest DDoS in history. Did everybody follow how the internet half went down a few days ago? This is what was happening. They were taking people's IoT devices, your fridge and whatnot, everything that's not supposed to be internet connected, but for some mysterious reason it's not internet connected, including routers and other things like that are just default, always on, nobody checks them, nobody secures them, and made it send heaps of traffic to a particular server called BYN, which is a DNS, giant DNS server for big companies like Amazon and Apple and some others that, yeah, were unreachable for a while. Okay, if you haven't seen this, you can come out under your rock. Headlines. This is how they did it. Like, this is an example of how you could collect such a device, right? Yeah, so you have a malicious page, and then you configure the access. You have open up this router so that it has incoming access, and then like on this port over here, if you connect to the port on that person's computer, you actually get access to the router, or change the remote password, or whatever it is that you want to do, right? So yeah, reset admin password, and so forth. So this is an old study, but yeah, put 50% back in 2006. The home routers had default passwords or no password. Yes. So with all those extra devices, you're buying like 100 kroner, my fridge can order stuff. It also has a default password. And then, not even just that, like, we're just finding out that a lot of these devices are made they're made for really cheap, so they're really crappy software. And a lot of that software just has backdoors. Because why not? It's like, oh, I had this thing, like this Jupyter firewall here has a backdoor because we needed to debug it. So there's a fixed login that you can do to any of these routers. It's really hard to upgrade because you have to upgrade the firmware and all sorts of stuff. Now, how do you defend against something like this? Does the concept make sense? Right? Okay. Good. So we could do two different things. We could say like, hey, really, if you're connecting to, say, a bank, what you want is that anything that I'm sending to the bank should be something that the bank has already offered me, right? It's like, oh, you want to do a transfer? Click this transfer button over here, and then it'll show you that. And what they're doing is that every time you click on something like that, they're sending this hidden token over here. And it says, I have seen this previous state, and here's how you get to the next state. So in other words, if I go on a random page at the bank, like this transfer page that didn't have everything set up, well, this hidden value would be missing. It would be like, there was no way you could have ended up on this page because you would have had to click something, that click would have had this extra hidden value attached to it. Does this make any sense? So this is great. Anybody see any possible problems with this though? Okay.
If someone gains access to your computer, then you just give that.
If somebody gets access to your computer, all of this that we're talking about with web security is already forfeit because they have all your cookies, they have all your stuff, right? All your default saved passwords, all your saved credit cards. Yeah, you're done. So make sure you have a screenshot of password and encrypt your hard drive, all these things. Other questions? Or any problems that you can see with this person over here?
Is it
Public source?
like people do the HTML page?
Uh-huh. Well, that HTML page that you're opening is tailored to you. right? You have already authenticated with the bank. You have a session open, which is what we're trying to protect. And then as part of that session, there's like, hey, I have shown this user the following hidden IDs, right? Actually, the way it's implemented is that there's this one token, and that's actually the problem. Is that there's one token that you can move from one state to the next state. That means that if you have two windows open and there are different parts of the page, which is why some pages are annoying like that, you're like, you can only have one copy of me open. I'm going to just crash right now. We're like, oh, it expired. Well, what's happening here is that you don't actually know the timing. Like, you don't know if this came before that. So you have some problems. Then there's referer validation, which the HTTP standard helpfully misspelled from the get-go. So it's a referer. The idea here is that the way you got to a page B was because you clicked on something on page A. So as a part of the request to page B, you say, hey, I was actually referred to that page, this other page over here. Now that's very useful. This was very interesting back in the day when we were doing something nefarious, and we saw all these people come on our page, and the referrer were like this .gov, .mail, or some like internal identifiers, some like watch lists and stuff. We're like, oh no, okay, we shut this down. Yeah, no, right. This thing here is just useful for you to be able to see, like, hey, I came here because I Googled it. I came here because I got all this information, right? It doesn't actually provide you with enough of security, especially not against cross-site request forgery, because you can usually pivot and have, like, I go to this page and then redirects on the page, and therefore the referer is gone, or the referer gets stripped, so forth, right? Then there's this thing called origin validation. Now, what is origin? So yeah, here in this case here the Firefox support is incomplete. We'll talk about origin in just a little bit. But let's go through the first one a little bit better. So secret token here. This is the unguessable token we talked about before. You could have that part of the token relate to your session identifier, to something that's dependent on your session or not dependent on your session, or it could be the HMAC of a session identifier. Well, what is an HMAC? Let me go down a little rabbit hole here. Suppose everybody knows hashing here, right? Suppose you wanted to sign something. You wanted to say like, hey, I wrote that. You say, hey, I wanted to do that. One thing you do is to say like, hey, here's like, or even if you wanted to encrypt something. What you can do is you can say, hey, I want to take this text that you have here, and I want to put like a key on it. So I can say I have here a key, and then this is the terminology for appending, adding on a string. There's a key, and here's your message, right? So this thing here is a hashing function, here's H. Okay? Now what could this could be one way in which I could sign the message, right? What do we mean by sign? It means that I alone would be able to say the number that came out of this is because I have my key and the message. You can verify things based on that key. Now, this is the first thing you would come up with if you're trying to make your own kind of signatures. And as it turns out, most hashing functions, if you know the value that comes out of this in here, you can actually add stuff at the end of the message and figure out what it's supposed to be. So you could, as an attacker, here's the evil person, they could actually say like, well, I know that this is some value X here. That means that I can actually, without knowing the key, I can create something that is a message and then like some stuff, evil stuff, right? Could be something like, hey, here's my message, and then at the end there's you're gonna download the stuff, or I'm gonna add the cross-site request forgery thing at the end. I can figure this out from X because I know that the state of the hashing function from X is such that if I wanted to add more stuff to it, I just keep iterating. Okay? It means that I can append stuff to this. So in other words, this is a pretty crappy signature method over here. So first thing people come up with It's easy to defeat because you can add stuff at the end. So what some people have come up with is like, well, you could flip it around and say, hey, I want to instead say, take the hash of the message and then the key. So like this, right? And then attackers have figured out a way, like, well, actually, if I can find two messages that hash to the same thing, I don't have to care about the key. So there's all sorts of things. So what people do instead is that they take this HMAC. So HMAC here is defined as effectively, it's the hash of the key and the hash of the key message. Like this. So now if I want to append anything to my message, well, I don't know what ended up in the middle. I effectively double hash, what the sense of it. It's an HMAC. I'm showing you this because this is stuff we talk about in cryptography, and if you do it in crypto, but it's just that people throw this word around like everybody knows what it is. We're like, HMAC? What's that? So the message authentication code, right? So, HMAC simply means there's a way for you to say there's a unique key that wrote it, and people can tinker with the result so that you can change whatever message there was in the signature of it, prompting suspicion. Anyway, so that could be one variant of ways to add a secret token here. So how does this work? Well, suppose here's a page here, it's like a slice host. It's like you can run resources like that, however easy to do. And as a part of your input, there's a hidden field over here that has some value. That's the value that's provided. So if you're looking at the source code you have in websites, I don't know how many people have spent any time doing this, but you will sometimes see weird things like this, like, hey, there's this like weird hidden value. Well, guess what? This is what it's doing. It's trying to make sure that the reason why it's seeing this value here is because it was sent before. It's kind of like saying, send me the secret handshake next time you talk to me, and I'll know that you did that, and not some random person impersonating. Does that make any sense? Okay. Now, refer validation. The problem here is that if you look at the header that comes from the refer, of course, if the attacker says, I come from evil.com and I'm here to transfer money, you can reject it. It's pretty fair, right? Or if you come from like the actual page, suppose it's Facebook or the bank or whatever, and that looks pretty legit because that's something that was issued for that. But what if it's just missing? Well, because it's an optional header refer. So if it's missing, you don't know what to do. And you can either be really lenient and say like, well, okay, you seem like a good person, and I'm just going to let you through, which is, of course, what all attackers love. Or you can be strict and say like, well, you didn't have a refer header. But then you actually break the internet, because a lot of browsers don't have this problem. That doesn't work either. Here's an attack that's maybe a little bit elaborate. It's fairly recent. So I kind of just wanted to show you a little bit what's going on the web. So this may be a little bit kind of a crash course in things breaking on the internet that we know and love, right? We're using the web every day in the browser and so forth. And there's just so many different things that can go wrong. So here's a recent thing. This is actually most probably relevant to people who are afraid of their states spying on them, for instance. Here's what you can do. And this is kind of an interesting idea. Suppose you're just this person talking to good.com, okay? And suppose that there's this malicious script, and this is something that the NSA has massive capability for doing. The Chinese have a firewall so that you can just add anything to any page so that you can track what you're doing and change what you're doing. And this is something that malicious parties that compromise ISPs and so forth sometimes do, inject stuff. This is something that the net neutrality debate is also touching, is that what if Xfinity adds JavaScript into your pages so that they can monitor what you're doing? Is that something they're supposed to do? Anyway, there's many different actors who could inject stuff into your page. And so if we force any requests here to go to a different page, one thing we can learn that we're not supposed to be able to learn is things like your password and so forth. Now that's kind of odd because there's no direct way in which evil.com can try to understand the password for good.com. But in this crime attack, what you learn is that if there's any compression happening or any encryption happening, then just knowing the length of what the request is that you sent will tell you a lot. Now, why is that? Well, it's because suppose that you're sending a request somewhere. Suppose your password is blah blah blah. Okay. Let's see. Blah blah blah. Okay. Okay, it's a name. And in the body of this request, there's another text that says, wow. Well, nothing would happen. In terms of compression, there are no strings here that you would benefit from compressing. But if as a part of your input, I type this, blah, then what compression is going to do is going to say like, hey, this part of this password over here, and this part of the content, they're the same thing. I'm going to put it in this Huffman tree, this kind of compression tree, and my message is now going to be short because there's redundancy. So what this evil person can do over there is to put in random strings and try to see if at some point you actually decrease the size of the message, in which case you've hit something that was in the actual packet. And of course, what you're searching for are things like your session identifiers or your passwords and so forth. And when things are HTML encoded, like you're writing one F as a character, this doesn't take a very long time to uncover your secrets. It's a very interesting attack. Just kind of wanted to put it out there here. Of course, this is beyond the realm of cross-enterprise forgery. At this point here, evil.com, this injection over here is happening by somebody who can almost control your internet connection. Let's talk a little bit about web frameworks, things to kind of tackle these things. Now, Ruby on Rails has some built-in protections. For instance, it allows you to automatically add all these tokens. So these tokens that we talked about here, you can just add it. And there's also in these frameworks like Django and so forth, you have this nice parameterized request like we talked about last time, where you can say like, hey, you don't actually have to write SQL queries. You can just kind of use the framework. And the framework figures out that like, hey, these parameters here, it's a string, therefore we need to add quotes and so forth. Right? This by in of itself does not protect against cross-site scripting, but there are some cross-site scripting, sanitization packages out there as well. How do they work? Well, they go through and figure out like, hey, here's a template for what the page is supposed to be like, and here's what the username or whatever came from the database. Whenever I'm printing something like this out, and I know that it's just supposed to be a string, I quote every single character that would be weird under HTML. Instead of writing actual less than b greater than that, I just write down the HTML character that will be rendered as less than greater than. So in other words, now if you're programming against Ruby on Rails here, you specifically have to instruct it that you want to allow HTML. You're in an HTML template, therefore it knows that you could possibly add cross-site scripting stuff, so it breaks it down like this, unless you instruct it not. So you have to really go out of your way to introduce vulnerability. It's great that we have this. You just have to use this framework correctly. Django has a bunch of cool stuff here. But of course, as we add more automation, you get new stuff. For instance, here's a PHP code. Anybody familiar with PHP here? Some people looked up. Yes. Can anybody find a way to exploit this vulnerability over here? First off, what is the vulnerability? So the underscore get is something that you get from the user. It's a part of your request. Somebody said colors equals something in the get request.
So it's instead of putting a color value as your photo, if I put my PHP file, it's gonna open up here.
Yes, but it's your PHP file, it's all gonna be relative to the server. So you can open up a different PHP file on the server, right? That's interesting, yeah. Can you do something more nefarious? This one really blew my mind. When I saw it, I was like, oh no, seriously? So, I could type here, I don't know, blue, right? And what's going to happen? It's going to try to open the file blue.php, right? We'll put in a slash or something. Slash, etc. Password. What's it going to try to do? It's going to try to open up the file slash etc slash pass wb dot php. That's no good.
But that would pass as a valid color.
It would pass as a valid color here. So now all of a sudden you can kind of probe around in the file system and can find everything that ends with .php. You might be able to put in here a percent point and say 00. That's one thing that people look for. Like, hey, that's HTML encode null, and put a null here. And now it's a question of whether include is working internally in strings or it's working in PHP strings. But that's not the bad part yet. If you, and get this, if you put in the file name http://evil.com, let's spell it correctly, /blah, then it is indeed going to resolve it as http://blah.php, and what will it do? Yes, it will open up that file from that host and execute it. There's just nothing that works in this web world. Like, everything is so broken beyond belief that, like, yeah, this is allowed. Makes you lose hope. Anyway, yeah, so we're gonna have red, blue, hidden dangerous. This one over here, perfect across the scripting text, right? You just add your own piece of code. You can do all sorts of fun stuff. Right? So, mass assignment. This is a Ruby on Rails specific one. So, because you want to automate more things, you can say, hey, I want all the parameters in the post to be in this array called form data, and then I create a new user out of it. And you intend for it to be in this array that looks like this. Hey, name is Dupurkit, email is Dupurkit, CV.edu, everything is great. Now what if you, how does that actually come to be? So there's a post request that happens when you hit create user, and each of these things is just separated out by ampersands, and there's an assignment from a key value pair separated by an equal sign. But what if you just add to that? I add admin equals true as a field. It wasn't a field in there. I just happened to have a guess or somehow know that in this database there's this thing called admin. What will happen? Well, this form data over here is going to now contain these fields. And it has no idea when it goes into user.new that this admin part here was from the internet. It's just creating a new user, and these are the three fields that it's going to update when it's creating that new user, including that admin field. Oh. At no point in this program was an attempt to say, here is what I expect that form to receive. Here's the fields. Here are the columns that I want to update from that. It got automated away. Make sense? Now, let's talk a little bit about malicious servers. and they're trying to attack your browser, right? So you recognize this, right? You have the visited links that look a little bit different, right? Somebody went through the effort to figure out the color of different things on what site. So they don't have access to exactly what you visited, but they can see the color that your cross-site scripting, like that your CSS template has put on your page. So they can see like, oh, must have been visited. Because it has that color. One way to do that, some reason one was just like, hey, let's look at the screen, as in like look at what the browser looks like right now, and just glean at pixels. If that pixel is blue or dark blue, I know something about what you visited. So you can use this as part of your attack. Let's see what's visited. Have you ever thought about how the like button works? Why wouldn't you? Suppose you're this evil person, which you're not, right? Nobody says no. Okay, fine. It's my destiny. Suppose you were an evil person and you wanted to have more lights on your face because you know reasons. Why wouldn't you just like put a like button and then automatically click it for people, right? Wouldn't that make sense to do? Why wouldn't you be able to do that? Suppose you put a different hat on your Facebook and you want to create a like button that doesn't have the property that people can just randomly click it for other people. Well, then you have to understand a little bit about the browser security model, right? So a like button, someone has to know about your Facebook session. In this case here, it knows that this must have been, that was supposed to be the first of your friends, so you and some others already like this. Someone has to already tag in with your Facebook session. But you don't want to leak all that Facebook session information to that weird page, whatever weird page wants to have a like button. Here, for instance, ESPN. ESPN has a like button right there, and it says, oh, tons of millions of people have liked this. Right? Now, how is that done? So, you would need somehow to get the cookie for Facebook.com so that you can say, like, hey, you're already authenticated, we know who you are, and therefore we can look you up in the database. And we want to be able to put it on websites that are not Facebook.com, but any website, right? That's what we want. And still, we don't want other scripts or whatever in the page to be able to click the like button or figure out the session that they can have. So this seems like not a prime thing to do on a website, right? Lots of risk. So, put your engineering hats on. Suppose you were designing stuff on the web. What would you need to be able to achieve this? What kind of tools do you need? It's like a Moses, like people on that side they look this direction, and that side they look on the wall over here, and I'm like, I have this pop, this chamber in here. Anybody? Well, how would you engineer browsers so that you could have these properties? Well, you'd like to be able to have maybe a part of the website that's somehow untouched by everything else, right? Suppose you're ESPN, and you'd like to say, like, this part of the website over here, it actually doesn't belong to ESPN, it belongs to Facebook. Right? That'd be nice. So in other words, nobody should be able to prod it or point at it or run scripts inside it or even see what's on there, right? So they made something called an iframe. Something that isolates this little block from the rest of the page. It's nice. So you can say, hey, here's an iframe, I'm in an iframe. You don't know what this embedded page is doing. The parent has no access to the embedded page. The embedded page is running this completely separate in a secure domain. It could be a completely different website. Yes?
But how do you get the code to put the like button onto the ESPN?
Yeah, so what you say is that in the parent page, you say like, hey, I want to open up an iframe, and the source of that iframe is some like button page from Facebook.com. That's it. And you just say it's this big, and Facebook handles the rest. And then Facebook provides that page effectively, right? And what's nice is that the ESPN can't then go in and click anything. It's like, it's just a separate, isolated thing. Makes sense, right? It's cool. Okay. So you can embed any page inside. Here's like, for instance, an iframe that embeds ESPN, just for fun. And you can share the same domain, however, if you share the same domain, you have ready access to everything inside your embedded page. You can add scripts, you can whatever. But if they're not from the same domain, meaning that ESPN.com and Facebook.com, if they're not the same domains, there's absolutely no cross-communication. So including that the iframe can't reach anything that's from the parent, because that would be a different kind of security vulnerability, right? Somebody accidentally puts in an iframe because it's part of a cross scripting, and now it can access everything inside your bank. That's not cool. So it's a very important security thing. Now, these rules here, they're part of something called the same origin policy. This is important for the browser security model, right? It says that the document object model, like the whole page here, from one page, cannot access anything on a page from somebody who has a different domain. The domain here means different host, port, and protocol, basically. So how does this work? This is what you write. Here's what ESPN.com has on the page. An iframe that has this ID, this internally has this weird name on here. Can't scroll on it, it doesn't have a scroll bar. It has this title, like, which comes in Facebook, and then it has a link to facebook.com/plugins, like, and an API key that says, hey, it's ESPN.com. It's the key that ESPN.com got. Something on here. And here's some style, like there's no particular style. Hide any overflows that happen. Here's the height, 20 pixels, weight, width, 80 pixels, and that's it. ESPN can't touch it, anything. Makes sense, right? Now put your hacker hat on. Suppose you really, really wanted those extra likes. Now what do? You've seen what we intend to do, and you've seen what the browser offers. You want to do some like jacking. How would you proceed?
Something that's not more popular than yours.
You could do that, but then if somebody hits the like button, they're liking that content. Some people do that just to kind of show, like, oh, look, millions of people like my crappy website. Amazing. You want your friends, eh? So I think, don't the like buttons now have some information about what page it is, or maybe not? But it doesn't really serve you. You have to get those likes, right? Well, what can we do? Okay, so policy prevents you from clicking the button and checking if it's clicked. What if the site can trick you into clicking that button without realizing? Yes. How would you do that? Oh, the internet is this endless source of hilarious entertainment. Look, click checking. Oh, why do you think there's a click for free iPad all over the place when you see ads on the internet? What do you think you're clicking when you click for a free iPad? That's right. You go up here. You didn't realize it. Oh. Oh no, you just liked somebody's page. You're like, I didn't like that page. Yes, you did. You just didn't realize it. You just wanted a free iPad. You didn't get one. Because surprise! There aren't any free iPads. Yeah, so it's when your malicious restriction to clicking on some element unintentionally, right? So that's one variant of it. Here's another one. Ha, put a fake cursor. Oh, you move your cursor. Oh, you think you're moving a cursor, but you're not. You're actually over the like button. As soon as you hit click a free icon, you hit the like button without realizing it. Oh, how sad. Oh no. Or yeah, you can even have the real cursor hidden so that you go up here and like, oh no, you liked it again. Oh, okay. Oh, over here. Let's skip this ad. How many people skip ads? Yes, don't you? Yes. Oh, what do you think people do when you skip ads here? Oh, you go up here and there's a fake cursor over here that you're really hitting. Allow camera, microphone access, or whatever it is that you want to access. Oh no! Okay, so now the malicious site has access to your webcam and whatnot because you want to skip that stupid ad. Yep. Or the hurting malware. Now this is something when we try to mitigate these types of attacks. Something that seems to work really well is whenever it's doing something that we think is profoundly weird, count down. Because then people get that moment's pause and they're like incessant click behavior to be like, maybe it's not a good idea to install some random JavaScript from some random place. This is fine. No, actually it's an add-on here. It's probably not fine. Adding a delay between button appearing and being usable prevents clickjacking. So that seems to be good. Now how about this one here? Oh, what would you like to, which one of these would you like for free? How about iPad? Oh, so you put another iPhone on top of it. So you maxed out everything except for the iPad part of the complete iPad purchase. Yeah, it's like, so you only see this thing here. Oh, iPad. Oh, that's like an iPad. So if you're somehow able to put sensitive buttons in an iframe, then you might be in trouble for clickbait. Yes?
If I had an ad block to install, wouldn't I like not ever fix this?
Well, if it figures out that the page that has this malicious thing, this is fairly malicious, right, is a part of an ad network and does this regularly and is therefore a part of your filters, then yeah, it would probably find that. But the whole point of this is not the ad. The whole point of it is to get some actual value from you liking the page. Or, in fact, so there are farms of, so this is the kind of clandestine companies whose job it is to sell likes, right? So you have like, oh, I have a crappy business. Nobody like shops at my ice cream store. I'm going to buy 50,000 likes. It's like the Silicon Valley plot. You remember this, right? So we get 50,000 likes from some weird page on the internet, Silicon Valley, the TV show. So yeah, you go to these companies, and what they do is that they're not going to just have some few people in the same place clicking things because that's so obvious to pick out for Facebook. So they do this. They put all these ads and all this stuff where people accidentally like random pages. And then they, of course, create fake accounts and so forth. So that's part of their strategy. And then they get money because somebody clicked or I like the page, so didn't intend to. Right? Yes. Oh, wonderful. Yes. Okay? So one of the things that people try to come up with against this specific types of attacks, and this like the whole collection of these, is that frame busting. Somehow, like, if you're not the top frame, you're just not going to work. So if somebody puts something in front of you or is blocking your view, you're not going to be happy. So one thing you could do is to do this. Say like, hey, if I am not the top page of the DOM, I am going to become the top page of the DOM. I'm going to say, I will be the thing that is furthest in front. Right? Bring to front, like in PowerPoint. That's kind of what you want to do here. Make sense? This is what you're trying to do. Yeah. If it were only this easy, right? So if there's any script here, if you're embedded in an iframe, somebody's going to squash you down and you don't realize that you're squashed down, this will break out of the frame and replace that embedded image. Otherwise it's not going to work. Of course, don't roll your own crypto, don't write your own sanitization, and please don't try to write your own fair investing solution because it's fraught with peril. So let's see this one here. Oh, it's top location, it's not self location. I'm going to change my parent location to P location. What do you do? How do you defeat this? If I replace my parent, just have two iframes. So an iframe with an iframe, and then you can only bust out one of them with this method. Oh, well, what about this one here that we just had? Like, if top is not self, I'm going to become the top here. Or If the embedding page said something called un before unload, which is kind of like when you see this stuff here, like, oh, the page or not, right? Well, you can block this script. So you can, the embedded page set this so that if you're replacing the location, it's going to have this one, and everybody here is like, no, 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 no. Let's stay on this page here. Or if you have your embedding page make a lot of requests, then they're automatically going to get this 204. Oh, like if they get 204, now content or special, you don't have any data. So this is a big cat and mouse game again, like everything else in security. This is something that seems to be a pretty robust way of doing it. You put in a body here, you try to find the body, and you make it into like a block. Otherwise, if you're not the top frame over here, you come to the top. Does this work without it? Yeah. Of course, all of this is pretty much just some JavaScript hack. And there's a good question of if there's any better way here. Here's something about frames. Whether or not a particular frame can be opened in just the same origin, or if it can be allowing some external things that can say, like, hey, this other domain here, or this list of other domains can also open this frame. And then get these types of security warnings. It's one option that people have come up with as another way of preventing these types of iframe attacks, but only some browsers support it. So many things will stop working if you enable it. Yeah, all this stuff. Here's the stuff on multi-party web applications. So suppose there's two different servers that are perfectly fine. They're good. They're benevolent. And then there's this evil user in the middle. Okay? Let's look at those scenarios. We looked at a bunch of different scenarios, so let's look at this one too. So there's two parties, and they are for some reason communicating. Maybe because they have to authenticate you, maybe because they have to perform a transaction on an external website. For some reason, there's two parties involved. Okay, so there's nothing that your browser can do to prevent these parties from talking to each other, right? So you're limited by that. Sometimes this is great, because for instance, remember when you sign on to a random page with a Google account, well, that's exactly what's happening. Somebody that site contacts Google and says, has this person actually authenticated? Oh, they have, great, okay, I'm gonna get the appropriate information and put it into my database as well. Okay. Now, yeah, here's the disclaimer, things have changed, things change really rapidly on the web, so not sure exactly how this works today because it keeps changing, but here's an idea. Suppose you have Jimmy's Army surplus, it's a page here, and it wants to just sell stuff using PayPal. Perfectly legitimate site, and a happy client. The way it normally works is that the client says, hey, I like that $40 vest because like, it's Halloween, or it's just my style. So you go in here, you get a redirect to say like, hey, to pay for that vest, you have to go to paypal.com, you have to pay $40, and you have to cite this transaction ID 123. So you go ahead and like, oh yeah, okay. Hey, PayPal, I'm going to pay for the transaction 123. It's a total of 40. And PayPal says, hey, okay, give me $40. Fine, I'm here for 40. Okay, cool. And now there's a message sent from PayPal to Jimmy Office that says, order 123. It's complete. Great, right? Now attack this. You can change the what? Oh yeah, you can just totally, couldn't you, right? You have this, just a transaction, you need to give some other number here, right? Yeah, why not, right? Shipping in the best, right? Oh, you will $40, 40, and you just say, hey, it's actually just $1. And PayPal says, oh, give me $1. Yeah, it's fine, here's the part. Okay, cool, I'm done with order 1, 2, 3. Now that would be really bad. So hopefully there's a mechanism that can do this a little bit better. What would you need to add to make this better? You can take, oh, you want to get also how much money was transferred? Hold that thought, and I'll break it later. But maybe there's something else here. Let's see. Here's something that addresses a lot of the possible problems. it has a callback saying like, when you're done, talk to Jimmy.com, and this whole thing, instead of you just giving only like is that here? It's signed by Jimmy, this whole thing. You can't change it. There's a signature and I'll validate it later. Now the client has to send like, hey, Paul, I'm supposed to pay here, and here's all this information I got from Jimmy. Right? So now we have a signature, everything's great. We're not tinkering with some of the contents. We would know exactly where the callback is supposed to be and can't change the callback to go somewhere else. Give me 40, here's my 40, redirect to Jimmy.com, and tell them that there's this, you've paid a total of 40, it's paid, and it's signed by PayPal, right? Great, okay, so we have the signed thing from PayPal saying like, hey, I paid you $40. Great, right? Signature checks. Can send the rest, okay? Now, why is this done like this? Well, it's because there's no actually back channel between PayPal and Jimmy. It's just a stylized way of saying, you are going to shuttle information back and forth. That's the thing. You do that redirect. So we have to trust you. So, if this is the case now, we're back into this world. How do you break this one? Suppose you're really nefarious. Can you replay it? Ooh, you could maybe replay it. In this case here, there's no ID for the transaction. Oh, that's true. There's nothing here that prevents replay attacks. Oh, bad. Yeah, I keep getting these vests. I keep paying 40, which is an old time stuff, right? That's bad. So probably you should have a transaction ID in here as a part of this term. I think it was in here, right? Right now, this response here should also have a transaction ID in it. So that's good. Here's an elaborate one. What about Eve's totally fake army surplus? This evil page that just popped up on the internet. Okay, and here's Eve, who's the control of that website. So your link. What we're going to do, we're going to say like, we're going to ask Jimmy here like, hey, I'd like that $40 vest. Oh, okay, that's fine. Just go to PayPal and say like, $40 and that ID this one. Call back to Jimmy. And what we're going to do, we're going to say, hey, redirect to PayPal.com with all the same information, except we are going to sign it ourselves in the Eve store. And so now PayPal says, so here's $40. Okay, redirect to Jimmy.com. Total was 40. The transaction ID was the same. It's paid, signed by PayPal. But where did the money go? We went to Eve, right? But the transaction ID was over here, right? Oh. Snap. You see how different and how difficult identity and authentication is on the internet? It's really a tough game. It's really read up on doing all this correctly. There's so many potential attacks you can hit. $40 ends up at Eve, right? So here's single sign-on open authentication. So let's see if we can go through this in time. Okay, so I'd like to sign on to Udacity with Facebook. Let's just go through this example over here. Facebook secret, here is Y, and Facebook knows that the secret thing that Udacity has is Y. So that's information that only the two of them have. Okay, and now let's sense this over here. And so it gets, oh yeah, you want to sign up with Facebook? Here's a redirect to Facebook. Includes all these things like a callback when you're done, and some identifier Z about this whole transaction. So you call and you're like, hey, Facebook, here's the callback, and here's the URL, and here's the Z, and all that stuff. And so now you get a little window, and opens up and says, now you want to give permission to Udacity to see all your stuff? And you're like, of course. So you say yes. And then, okay, fine, here's a special token called X. Redirect to callback with identifier Z. Okay? So you get the callback back here, you get the token X, which says, hey, I have authenticated, this is me, and I'm user Z. And now, in the back end, and this is actual back end, this is not just shuttling to the user. There's a request from a server at Udacity saying, hey, who has this token X? So there's a user here that has token X. And by the way, I am Y over here. So whoever authenticated against Y earlier, and has a token X. Can you give me the information about them? And they're like, yeah, it's Alice. She goes, fine, friends. Okay. So now you're authenticated as Alice, and everything is good. Okay? Suppose Eve comes back. Evil Eve. What does he do? Hey, I'd like to sign in with Facebook. Oh, great. Okay, yeah, so just redirect to Facebook with this identifier here. She calls her friend, Alice. Hey, Alice. What's happening? Can you click this link for me? It doesn't work for me. Like, does it work on your computer? Or like, hey, there's a really cool movie out and it's free on the internet right now. You can check it out. Well, you have to do it really, really quickly. So Alice is going to click this link. What will happen? So she's going to send this identifier Z. She's going to send the callback. She's going to give a question like permission to do that. She's like, oh, okay, sure. This actually happened. This actually did that. Okay. I mean, have you seen how many people let Candy Crush at every information about them? Right? Yeah. Here's a special token X. Redirect the callback with an identifier Z. So go back to Udacity with the token X for user Z. But who initiated this whole party, this proposal? Eve did. So now that we're completed here, who has token X? Oh, it's Alice. She has 5 friends. So you're effectively authenticated with Alice, but because Eve was initially receiving the request from Udacity, she effectively owns that session. She has all the information she needs to go to Udacity and say, hey, I'm this person who just authenticated, right? Remember you gave me that Z value like that? That's me. You are now Alice. Ah. This is fixed in OAuth 2.0. It's fairly recent. It's called the session fixation attack. Okay, I wanted to just briefly show you something because it's so much fun to play with. Escape.elf.new, I think it's called. Let's see if this works. So here's, escape elf. ALF? Oh, here we go, yeah. Okay, it's just me being a little bit slow today. My apologies. Really? Escape elf new? What happened to it? Did it go away? No. Huh. Escape dot. Did I type it wrong? Escape elf new. Just killed my old name server. Oh, I see. Oh, okay. Internet argument of a copy. Let's see if that works. Here we go. Okay, we're in the Wayback Machine. So these are all these like different stages here, which are really fun. Let's see. Does this all work? And so you have to go in here. You have to type stuff. You can type in here name like Ymir and some input here. And as you do stuff. Okay, it's all Borky because of Wayback Machine. What happens? Yeah, okay, this is not going to be fun. What happens is that you can type stuff in here, and it will just show you what does the source code look like, what is the render diagram, and can you break out of this JavaScript stuff that's in here. We'll have a lab on the similar stuff. I just kind of wanted to give you a heads up, but we're out of time anyway, so it's just not that. Any questions about Joy Lab before tomorrow? So I have officers tomorrow, what, 2:15 to 3 or something like that? And yeah, that's it, I guess. Any questions? You can talk to me now if you want to. Cool, thanks.